Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 1.5. I believe this is non-linear solve for x or something. We're going to be factoring and stuff. So, here we go. 151. I typically like to do the first problem of the homework anyways. So, we have this equation, and I need to solve for x. Trying to make that x look a little better there. And it says use factoring to solve for x. Use factoring. Okay. I believe that there are two boxes that we actually have to fill in. Something kind of like this here. So we're going to have to factor it, and then we go and solve for x after that. Factoring this thing is not too bad. I'm looking for two numbers that multiply to the 28 but add up to the 3. Things that multiply to 28, I'm thinking like a 4 and a 4 times 7. And would a 4 and a 7 make a 3 somehow? Yes. Notice it's a negative 3. So if I had a negative 7 and a positive 4, that should yield, when I put them together, that negative 3. Also, when I multiply them, I should get the negative 28. So that's, that's my answer. Ta-da! Wow, that was easy. And of course, we've done this a whole lot. Just switch the signs. So it's now it was a negative 7, now it's a positive 7. It was a positive 4, now it's a negative 4. And we've solved for x. 1, 5, 11. So I've got 3x times x minus 3 is equal to 11x squared minus 16x. Solve for x. And if it doesn't say use factoring, I'm going to say use factoring. Well, first off, let's simplify this thing. I got 3x squared minus 9x is equal to 11x squared minus 16x. If I minus the 3x squared to the other side, I would get, what, 8x squared? And then I'm going to add the 16x to both sides. And so that would yield a 7x. Okay, pause. So this is really cool. Back in the day, when I was a student, I said, "Oh, there's x on both sides. Let's cancel it." And then we could solve for x super easy. That is incorrect. I mean, yes, it will get you one of the answers, but there's another one that you're getting rid of. I don't think that's the good way to go. So I wanted to teach you correctly because, well, I messed up for so long. I might as well teach you the right way to do it, I guess. I'm going to move this to the other side, so I'm subtracting 7x on both sides. So we have this. Now I'm going to factor it, okay? Notice, what do they have in common? An x. They have a single x in common. And so when I start solving for x, I got this guy and this one here that we have to solve for individually. Well, x by itself, it's going to be x equals 0. The reason why is because there's no numbers there. I mean, it's kind of like there's a factor here, kind of like this. It's the same as saying this, I guess. See? So I'm saying that there's this. So what solve for x, what do you get? You get a 0. See what I'm kind of getting at there? Hopefully. It's just all by itself, it's a 0. That's all you need to know. Over here, though, it's a little bit more complicated. So I'm going to go a couple steps on this one. I'm going to add 7 to both sides. And I'm going to divide by the 8. So then we get 7/8. And so both of these are answers. So x equals what? 0, 7/8. There you go. Cool. Let's keep going. I got 1, 5, 15. I got 6x squared is equal to 24. It says solve using square root. Okay, I guess. Square root. So, first off, I don't want to take a square root immediately. I know that's one way to do it, but that'll be ugly. I want to divide by 6 first. I want to make it, like, easier. 24 divided by 6 is just a 4. Look how much easier that is than what we would have been trying to tackle. They say to use a square root, so I will. I'm going to square root both sides. There is a rule. There is a rule. When I do the square root of both sides kind of thing, you must have a plus and a minus for your answers. And so a square root of 4 is just a 2, so we got plus and minus 2. That's your answers. Like, that's it. 2, negative 2. You could, in my math lab, use the plus minus button here. I'm pretty sure it'll work. So either way is fine. These are both good. So there's your little rule. Whenever you do a square root of both sides, remember to put plus and minus. Very important there. I'm kind of assuming you've at least heard of that before, but at the same time, I don't want to assume too much. I'm going to add 8 to both sides here. And I'm getting a little bit of a, I don't know, I'm getting scared. I don't know if you're noticing something here. Negative? I'm going to divide by the 2. Still a negative. Something's wrong here. I'm not really sure what they're wanting. So often I'm very fast about just seeing the problem, getting it done. And, you know, they got words and words. Who cares about words, right? Well, in this case, they're actually important. When you're reading it, they mention something. They mention I. I can't remember if it's italicized or bolded or both or something like that, but I is the square root of negative 1. Okay, so that's what an I is. I stands for imaginary numbers. Hey, we're going to see that in this class. Not a whole lot, though. We're going to it'll be here and there just a little bit, but this is important because obviously this is on your homework. I squared is equal to negative 1. That's another formula, but both of these are important to you. In this particular case, what we're wanting to do is tackle that minus sign in the front somehow. Let me show you. So I'm going to square root both sides, right? That's how you get square root and square cancel one another. That's the point here. Cool. So these cancel, leaving an x. Great. Oh, and you got to have a plus minus, right? But I'm left with this square root of a negative, and when you put that in a calculator, any normal calculator, it will error. It'll blow up on you. You don't want that. But what is okay is the square root of 100. That's just 10. We like that. So how do I get rid of that minus sign so that it's easier? And so the quick answer, very quickly, is that you're going to take the square root of 100 as a 10, and you had a negative, so you just put an I in there. And there you go. You're done. That's actually the answer. You could also put, in my math lab either way, the 10i, comma, negative 10i. Both of these are totally fine. So that's the quick version. Whenever you have a negative square root, just put an I on there. Keep walking. No need to talk about all this stuff. I'm going to go a little bit longer just in case you want to see it. So this is what we're looking at. And I'm going to split this thing up to a negative 1 and a 100. Okay? Doing that on purpose because I can split my square roots up like this whenever they're all multiplied. Well, there's a formula for this thing. And then that's just a 10. And so you can see how I got the 10i now. Okay? You don't have to go that far. You can just say, negative, put an I on there. Good enough for me. Good enough for my math lab. 1, 5, 29. So I've got 7x plus 4 all squared is equal to 81. There we go. Okay, solve for x. I can't remember if they actually put some kind of hint on it or not, but if I got a square, I want to square root it almost immediately. I have no other idea of what to do. I think this is going to be the best. So square and square root, they cancel one another. Remember, when you got a square root of both sides, you got to have plus and minus. And the square root of 81 is simply a 9. So what we're left with here is a plus and minus 9. What we're going to have is two answers for sure. But they're going to be wildly different answers because I have to still do a lot of math with it all. There are definitely ways to do this problem more officially. You do this and you solve it. And then you do this and you solve it. And you got an answer and you got an answer. That's fine. Yeah. I'm going to do it my way. So I'm going to just leave a plus minus on there and it'll be okay. This could mess you up, of course, but as long as you're keeping that plus minus next to it, you should be fine. So I'm going to just say minus 4 on both sides. Notice I'm just keeping that plus minus with it. just another number. Divide by 7 on both sides. Just keeping that plus minus with it. There you go. That's your answer. I don't think my math lab will take this simply because it's not simplified. I would say it's just simply not simplified. Huh? Funny how I say that. But think about it right now. We're in Math 1414. We're proposing, we're considering the fact that you're going to be moving on to pre-calculus, to calculus, and moving on all the way, right? And currently, right now, we're using my math lab for algebra, but for pre-calculus and calculus and above, we're using WebAssign. And WebAssign is not very picky about simplifying things. Like, basically, this would be good as long as you're in pre-calculus or calculus. The idea is that you've already done all this, you know what's going on. We all assume you can simplify because you made it this far, so it's not a big deal. But here in my math lab, they are picky, and that's okay. It's good to, get trained in this stuff, so we're going to simplify this, okay? I'm just saying, in the future, because I know you're going to see this in the future, this is okay. This is okay. All right, so I'm going to split it up into two separate ones now. I got a positive 9 minus 4 over 7. Then I got a negative 9 minus the 4 all over 7. So positive 9 minus 4 is a 5. So we got 5/7. On this side here, we got a negative 13 over 7. And, well, that's it. We're done. So there you go. Cool. And I'm giving you a taste of what pre-calculus will be like as well. 1, 5, 35. We got x squared plus 12x. Wow, that's not a lot. They say, what is the constant term to make a perfect square? What? Constant term to make a perfect square. What are they talking about? Well, what they're trying to get out is this thing called complete the square. Complete the square. I don't think they say that on the problem. Surely later they do. But this is a particular thing. Like, say that I say some words to you like factor. You think something in particular. A certain process. When I say quadratic formula, well, you think a certain process. There's a certain thing that comes to mind. So when I say complete the square, this is what should come to mind. This is, again, I would not call this review. This is maybe something new to you. And so when I say complete the square, and we're going to do it a couple times, this is what we're going to be doing here, okay? What they want is they want to add some kind of number here to make this into something very pretty, factors, in particular with a square, to make it look really pretty, okay? So this whole thing ends up like this just because we add something simple to it, okay? There's a process to find that number. We're going to take the middle number here, that 12, and we're going to divide it by 2, always by 2. So take whatever number you have, divide it by 2, and we get a 6, obviously. And then you take that number that you got, and you're going to square it, always square it. So you're always going to divide, you're always going to square it. Well, it's 36, I just said it. And that's the number that you're wanting to add to this thing so that it could be factored. So you factor this thing now. What two numbers? Multiply the 36 but add to 12, and you're like, oh, it's 6. 6 and 6. And that's like your final answer to this thing. Notice this number here is always what goes in there. Even if it's negative or positive, it'll be negative and positive there. So there's a lot of coolness going on there. It's pretty neat. Now, you might be thinking, and I hope maybe you're thinking, how can you just add a number to this thing just because? Well, right now we're doing it just because my MATLAB says so. But in the future, when we complete the square, we're going to have to both add and subtract that number, to make it proper. And I'll definitely show you that here in just a couple minutes when it comes up. Okay. I think what they're wanting here is two different answers. I think. Yeah. Okay, so let me list out what they're wanting here. This, I believe, is part A. This is part B. You just have to type the whole thing again. And then this is part C. I'm pretty sure. I have all those boxed in. It seems that those are what they're wanting, okay? So I can't remember. Maybe there's no part A, but you do part B and C or something. Something like that. Type a lot. Make it work. There you go. So next one. 1, 5, 37. I got x squared minus the 8x plus the 16. Oh, I gave it away. Wah, wah, wah. So, same process as last time. Complete the square. No way it's a 16. No way. Okay, well, sorry about that, guys. So, I was just so excited. Take this middle number. This is the procedure. Take the middle number, -8, and we're going to divide it by 2 to get a -4. I'm then going to take that number, whatever it is, -4, and I'm going to square the whole thing. I'm squaring the whole thing, even the negative sign right there, okay? So 2 negatives are going to always make a positive. 16 here in this case. And that's how we got the 16 for that answer. Divide by 2, square it. Divide by 2, square it. And so we got 2 answers here. You need to write the whole thing out, and then you need to factor it. So part A, part B, or part B and part C, I can't remember. So it's going to be a square because we're completing the square. I wonder what number goes inside there. What 2 numbers multiply to 16 but add up to 8? Oh, it's 4 and 4. But notice that the 8 is negative. So therefore, it should be a -4. Oh, wait. It was right there the whole time. You see what I'm saying? It's already done for you. You just simply say, that's that number. Bloop. Done. Okay. Now we're going to do a real complete the square. A real one. Yep. So I got x squared plus 4x plus 2 is equal to 0. And they say complete the square. I think they actually say it this time, which is nice of them. Well, this is different because it actually has a constant term now. And let's just say I wanted to factor this thing right here. What 2 numbers multiply to 2 but add up to 4? And you're thinking, well, 2 and 2. Well, no, 2 times 2 is not 2. It's 2 times 1, and 2 plus 1 is only a 3. It's not a 4. Basically, I'm trying to do this thing, and it's not going to work. And that's the point of complete the square. We're trying to do something to this in order to make it better looking. Okay? You won't want to do it every time, but especially when they say it, go ahead and do it. What I want to do for complete the square here is I want to imagine that there's a number that I'm going to both add and subtract in order to get this better looking. Notice that I'm still having the 2 in there. That is one of the most commonly missed things when you're doing this, is that you just almost forget the 2 even exists because you're so focused on all this other stuff. So just watch out. I mean, again, I've done this stuff. I've messed that up myself, so that's why I'm telling you. So I've got the 4 here, and I'm going to divide it by 2 to make a 2. Again, that's positive. This is positive. And then I'm going to take that 2, and I'm going to square it to make a 4. It's kind of funny that we got back to 4 again. But I want to put it in both boxes. Now, why in particular do I have 2 boxes here? I don't even think my math lab has that. I have it because it's a plus and a minus. Like, I'm adding 4 and I'm subtracting 4. Did I change the problem? And the answer is actually no, I didn't change it at all. This is a legal move. This is a good move. Okay? I know it makes it more complicated, but I didn't actually change anything. I didn't alter it. It might look a little bit more altered, but it's not really. This just gets back to this. Simplify. What do you get? The same thing as the original. So I'm not doing anything wrong. That's the point here. So this is what we have. What we really are interested in are these guys right here. I want to say, hey, if I just look at this, I don't know, group. That's a good name for it, this group. Can I factor this group somehow? I don't want to say factor by grouping, but you get the point. It's a group. And I'm saying, what 2 numbers multiply up to 2? Oh, I'm sorry, multiply up to 4. I did it again. Multiply up to 4, but then add up to 4. Well, 2 times 2. We already knew that. The leftovers are still important, and so I have to use them in order to, complete this problem here. Will I have a -2 out of those? Again, whatever yields, whatever is yielded from that, that's fine. Could be something different next time. Who knows? And so this is my new equation that I'm going to start solving stuff with, okay? I want to now solve for x or whatever they're wanting me to do here. And I know that it might not look a lot more pretty than the original, but honestly, this is much better. Again, like I was saying, factor this thing. What two numbers? Multiply up to 2, but add up to 4. And there's nothing. We already went through that. But is there a way to solve this one here? Is there some other way to solve it? And I'm going to say yes. I'm going to show you. What if I add the 2 to both sides? That's pretty simple. There's a lot of 2's going on here. Oh, I got a square, so I should probably square root it. Notice that I'm not trying to square root it beforehand because that would just make a huge mess. You don't want that. Square root it when it looks like this. 2 terms, one on the side, one on one side, one on the other. So the square and the square root cancel. You can kind of do that. But it still leaves behind the x plus 2, whatever's on the inside. And whenever I do a square root, I got to have a plus and a minus. Now, there's no simplifying a square root 2. It's just 1.414, blah, blah, blah. So it's just a never-ending decimal here. We're going to leave it in exact form. I want to solve for x. I want to get x by itself. So I'm going to minus 2 on both sides. Make sure that square root ends there. And this actually is your answer. That's what my math lab wants. You could type it just like that, or again, you could do the square root of 2 minus 2, comma, square root of 2 plus... Whoa. I put my plus and minus in the wrong place. There you go. And make sure that square root does not continue. On my math lab, whenever you do the square root button at the bottom, it pops up, and you put a 2 in, and then arrow to the right or something. Get out of that square root. You do not want to have this. That is incorrect. You want it like this. Okay, that's better. Well, that was a big problem. Again, it really wasn't a big problem. I was just explaining a lot. Just recap if you want to. Let's do a recap. I can't factor it, so what do? It says complete the square. So I do this plus and minus thing. We already went through that a lot. I see this right here is factorable to something pretty. I got some leftovers. Then I say, I could solve for this. Move it over, square root both sides, and there we go. It's really not too bad. The point of complete the square is that we should be able to simplify it down a bit. So this one here, it might say complete the square. It might say just solve. I have just solve. It doesn't. It's kind of like generalized, I guess you can say. I don't think I could factor this. I mean, come on. What two numbers multiply to 3 but add up to 5? 3 and 1 multiply to 3, but 3 and 1 do not add up to a 5. So that doesn't work. We could complete the square, 5, and then divide by 2, and then square it. I'm going to get fractions. I don't really like fractions. So is there something... Here, just think about it. Is there something that we could do to solve any one of these equations, any one of these quadratic equations? Yes, it's the quadratic formula. Yep, quadratic formula. Quad form. Good enough. So I'm going to go ahead and give it to you. It's a negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I'm using capital letters because my lower cases are not as good. My upper cases are not as good. But this is okay. It's clear to see, and I'm very much assuming that you've at least seen this before. As far as actually using it, well, maybe it's been a while. Maybe it's been yesterday. I don't know. Let's just do quadratic formula because it's cool. It's cool. It is. So just in case you don't recognize or know or it's been a while, A, B, and C are your variables. There's not any number in the front, so A is just a 1. B and C are numbers. Put them all in and I'll get an answer. So I got negative 5 plus or minus the square root of 5 squared minus 4 times the 1 times the 3 all divided by 2 times 1. So I believe that 5 squared is 25, and here we got a minus 12. What I'm seeing here is a 13, square root of 13. And, well, we're done. That's it. There's nothing else that I can do when I see a square root 13. What is the square root of 13? I don't know. It doesn't simplify. So at this point, we're done. And you can type this in exactly as it is in my math lab with the plus and minus. Of course, you can do the longer way too. But at some point, it's like, annoying. So either way does work, of course. In the future, so we might need to simplify this a little bit here. In fact, I think it's the next problem. And sometimes, I wouldn't put it past them, that we might have to do imaginary numbers. So if you have a negative, you just put an I next to it and you keep going. So I'm not too worried about that. I am a little bit worried about simplifying it, though. So let's do another problem where, I don't know, we probably ought to simplify it. Wow, it's just like I know what's going on here. So x squared plus 2x equals 10 equals 10. We need to move this guy over to make it quadratic form, I guess? I don't know. So that I can do quadratic formula. And that's a 1, 2, and a negative 10. So negative 2 plus or minus the square root of 2 squared minus 4 times the 1 times the negative 10. All divided by 2 times 1. And so, simplifying this a little bit, we got 4 squared. 2 squared is 4. 2 negatives make a positive 40. Plus and minus 44. Now, that's my answer. And if you type this into my math lab, it'll give you a very interesting response. It'll say, although your answer is equal to the correct answer, blah, 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 simplify. So, because you get 3 attempts on every problem, I mean, honestly, it is telling you that you are in the right direction, so that's good. You get 2 more attempts after the first try there, so plenty of more attempts for us to simplify this thing. What do they mean? They mean that 44. That 44 can simplify somehow. I want to know what prime factors are included with 44. And so this is how I do it. This is just me. I got 44. I say, hey, is there a 2 in there? You say, yeah. It's 2 and 22. I say, okay, cool. Hey, is there a 2 in there? Yeah, it's 2 and 11. Okay. Is there a 2 in there? No. Is there a 3 in there? No. Is there a 4 in there? Well, I don't want to. It's 5. Prime factors. Is there a 5 in there? No. Blah, 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 blah. No, 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 no. 11 is prime. So you're done. You're done simplifying. In fact, these are your prime factors. You can say that 44 is equal to 2 times 11. And that's legit. I mean, you can go to the calculator and try that thing. I'm going to rewrite my square root inside like that. Oh, not 22. 2 times 11, all on the inside of that square root. I know there's a lot of 2's now. The point of me doing this is that I'm able now to pull out the pairs to the front of the square root. Pull out the pairs. Now, I'm sure there's other ways of saying this. You could even imagine this as a square root 4 times the square root of 11. Well, what's the square root of 4? It's a 2. Lots of different ways, and that's totally fine. I like pull out the pairs. That's what I do, so I'm teaching it to you as well. Basically, if I have a pair of numbers, I put it in the front. And I would continue to do that with every pair. If I had like a 3 and then another 3, I'd pull a 3 out to the front as a single 3. So pull out the pairs. It's now from 2 2's now to a single 2, and there we go. Still, this is good, but I know that we can simplify this a little bit more. Another term that I use is distribute denominator. Distribute denominator. Both of these guys are both divided by 2, and so we could simply say negative 2 over 2, and then the 2 squared 11 over 2. This guy simplifies. These 2's cancel and simplify. You can put a 1 in the front if you like. But that's basically your answer. Whew. I know it took a long time. I think it takes a long time just because I'm explaining it to you. And I'm trying to give you some of the nitty-gritties. I'm trying to give you the terms and stuff like that. When you're actually doing it yourself, it doesn't honestly have to take this long. I mean, it can, but I hope not on every single one. So 15131. I got a capital N is equal to t squared minus t all over 2. And blah, 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 lots of words. Something about chess games. Again, I'm just giving you the most important information here. We got capital N is the number of games. And I got a little t is equal to the players. Okay. They say, blah, 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 21 games are played. How many players? So this is a very important question here. Mainly because it has, I've seen it come up again and again, so that's something. But it's a lot of words in particular, and I don't know, we get scared of word problems. I don't know, I don't like word problems. But when it comes down to it, it's just a formula. We're going to plug stuff in and solve for something. N is equal to games. So this must be my N. I'm going to say 21 is equal to t squared minus t all over 2. Solve for t. How many players? I'm going to multiply it by the 2 on the other side, making a 42 over here. I'm then going to minus the 42 on both sides. And then I want to factor this. I'm thinking, what 2 numbers multiply to the 42, but then add up to a 1? See the 1 right there, invisible 1? Well, 42, isn't that like 7 and 6 or something like that? So if I had a negative 7 and a positive 6, that would yield that negative 1 in the middle. So I like that. And of course, my answers then would be 7 and negative 6. Cool. The thing is, though, to say how many players are playing these chess games, can players be negative? No. So it's only this one, because that's the only positive answer. It's the only one that makes sense. Okay. I have one last problem. 15149. Can't let these application problems go. No way. Gotta talk about them. I probably am not doing every single one of them, but at least it's something. It's a pool. It's a pool of water, like, you know, swimming pool. And we got an X for the sidewalk, the pavement around it, and here's your water. And they also give me, this is all in a picture, 20 plus 2x, and on this side we got 26 plus 2x. Okay, awesome. They say if the total area is equal to 952, then solve for x. Now, what they're trying to say by total area is literally the total area here, okay? Now, I don't know why these little x's are in there. I mean, it's cool and all, but when it comes down to it, what's your area of the whole rectangle? It's length times width. I mean, I'm not kidding you. That's it. Length times width is your area, right? So then I got 26 plus 2x. 20 plus 2x is equal to 952. And then we solve for x. Solve. So, blah, 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 pictures, words. Oh, no, I don't know what to do. Well, that's what you're going to do. Now you just go and solve it. I'm going to tell you that this one is not as easy. No, it's not. You're going to have to FOIL this thing to start with. I'm going to do a little bit of it with you. I actually have not done it on my paper. I just said, well, you know, y'all figure it out. And that's okay. It's okay for me to do that sometimes. But I'm going to FOIL this thing out here. I keep saying FOIL. Distribute. Some people don't like FOIL, but whatever. So 26 times 20. I got a 520. 26 times 2 is 52. 20x. I got 2 times the 20 is 40x, and then 2 times the 2 is a 4x squared. To make this into a quadratic form, I guess you could say, combine these like terms and subtract the 952 to the other side, leaving behind a 4x squared plus 52 plus 40 is 92x, and then a minus, so I got 520 minus the 952 is a negative 432. I wonder if all these are divisible by 4, because otherwise it would be really tough for me to want to do this. So they all are divisible by 4. I can factor a 4 out to the front, leaving behind a 23x and a 108. Now, let's just pause on this. There's these little rules, I guess, or reminders of what's going on here. I got a 4 in the front because this is way easier to factor. I mean, here at this point, I can just do that, right? Even if they're big numbers, it's still going to be something manageable. This 4, though, what happens to him? I mean, blah, 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 equals 0. What do I do? Well, I'm going to be funny. I'm going to divide both sides by 4. Right? I mean, I can do it. That's a legit move. What's 0 divided by 4? Come on, try the calculator. What do you get? 0. It disappears. That 4 just goes away. Because although he was part of the original problem, he's not going to help me solve for x. That's the thing here. I want to solve for x. So then, was he helping me? Nope. So he's gone. Now I can actually factor this thing down and get two numbers multiply to 108, but add up to 23, blah, 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 blah. You get the idea now. It's not too bad. And that's where I'm going to stop. So you could see the process, where I'm coming from there, and I know that you can finish it up. All right, that's all I got. Thank you very much, guys. Have a great day.